So how did we end up making filament inside the United States for $10 a spool? This project actually started almost a year and a half or 2 years ago. We had made a video talking about a lot of the basic problems with filament, with manufactured filament. Things like the kink at the end of the spool and how it wasn't made in the correct format spools and yada, yada, yada. Basically whining on the internet. And at the time, a lot of people on the internet said, well, you're making filament for your own print farm. Why don't you just go ahead and make filament and change all that stuff? And our response to that was no. We did not want to do that because making filament was for other people was completely different than making filament for ourselves. And we ended up making a video about that, explaining why filament costs what it does. And not to redo that video, but filament costs what it does for like a number of different reasons. You have, if filament costs like 25 bucks, you have about $5 for the raw materials itself, a couple dollars for the processing, packing, and so on and so forth. And then you have about 25% of that for marketing. You might have 10 to 25% of that for the wholesaler or distributor if you're like selling on Amazon. And then of course you have shipping, because the cost to ship a spool of filament is about $8, depending on how efficiently you do it and how you do it all that way. So there's just a lot of expenses in making filament. So even if you do make the final spool more cheaply, getting rid of the rest of the stuff is really expensive. But that is for a spool of filament that costs $25. The issue has always kind of been that like US filament manufacturers generally sell filament for about $35. And that started to seem a little bit wide. They would generally justify it as in higher labor costs and, oh, made in the USA is better quality, but that's not really true. Filament has very little labor attached to it. There are ways where it can go wrong. Right here on this machine, this spooler right here, a person, if the filament line is running really fast, a person might have to stand here and change out a spool every couple of minutes or so in order to swap over and swap around, and that can be really expensive. The labor isn't really the issue. That can all be done around the world. So let's just go ahead and dive into how we did it. We decided that we would actually make consumer filament and start working through the issues of how to get it done. And when we started, the filament was $22 a spool. But over the course of a year, we got that down to $10 a spool underneath a subscription, which we'll get to here in just a second. When we started, the big thing was we could not use any of our existing capacity. We couldn't use any of our existing extruders because we needed those to make filament inside of our print farm. Because in case you didn't know, we're not actually a filament manufacturer. Slant 3D is actually a print farm operator. So we operate hundreds of thousands of machines making parts for other people. Like they'll connect their Etsy store to us and we will print and ship their parts for them. So we make filament for ourselves in order to get the cost of that production down lower. But in order to add in more filament, we would have needed more capacity, which is why this machine came into it all. And this machine was really the only reason we did Tangled at all, because we were able to find this machine. And when you get a machine for cheap, you get what you pay for, but it did allow us to start making filament and getting it out the door and working through, okay, what are the scaling problems with filament? And many of the scaling problems are the same as when you're making filament for yourself. Oh, you need to make a lot of it. You need to make a lot of it fast. It has to be good quality, blah, 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 blah. Consumer filament has all the trouble of having to be packaged up still sustainably, survive shipping, all those problems that we then had to learn about. So this extruder let us start learning about that by sending stuff out. So the first thing that we did in order to get the filament kind of up was we eliminated the 1 kg spool, or at least reduced it. If you do not have to change out the spool multiple times, all you have to do, you are able to reduce the labor by about 60% across 3 kilograms of spools. So we just made a 3 kilogram spool right off the bat, so that people could get the cost savings of not having to buy 3 spools and buy the labor of 3 spools. We worked through the normal production process that we'd been using all the time of like allowing the extrusion line to run 24/7. This is actually fairly easy because even though a lot of people will only operate for an 8-hour or maybe a 12-hour shift or so with normal extrusion, it can actually basically run overnight so long as you have some way of spooling it at the other end. Extrusion itself is very, very efficient and highly automatable and really stable once it's operating. So there's no reason to really have people standing by all the time. But that spooling is kind of the challenge. While there is machinery out there now that is able to spool onto 1 kg spools continuously, it's a little bit finicky and it's very much expensive. And that's really true if you're trying to reduce the cost of filament. You don't really want a lot of expensive machinery because then the time of amortization is all still there. So the solution that we did was automation. And a lot of people really overcomplicate automation. You say automation, people think custom machine or robot arm, but that's not really the case. Automation just means reduced human effort. And reduced human effort can just mean a bigger spooler. If a spool used to be need to be changed every 5 minutes, you get a bigger spool, and now you're changing it every half hour. Or you get a real big spool, and now you're changing it every 6 to 12 hours. And then that big spool is able to store up all the material, and at some point in the future, it can be put on a down spooler and spooled onto 1 kg spools, with whatever piece of machinery you want to do or with whatever labor, but it's all way more efficient. And that was kind of one of the main things that we did and had been doing when we were producing it ourselves. In order to run overnight, you just get a great big old spooler, and that is handier and more affordable than additional automated machinery. Over the years, we had messed with many different automation techniques, and we had done the robot arms, and we had done the custom jigs that could spool up 10 1 kg spools and that kind of thing. But all of them were kind of limited. So you just go to simpler is better, and a great big old spool to store up a bunch of filament is simpler and better. It's really reliable. So that reduced the labor component of the material, but then you still have the cost of the material itself. And the way we dealt with that was really just the benefit of Tangled itself. If you drop the cost of something way down, a lot more people will buy it, so that you can buy a lot more of that stuff, so that the cost can then drop lower. It's a very Fordian kind of idea. Oh, if we drop the cost, more people will buy it, which means that we can buy more of our stuff at a greater scale, so you get all the economies of scale that volume gives you. And that's pretty much the game we're playing with Tangled. And that played out literally just this year when we bought about 20,000 pounds of PLA at a really good deal, because we could and we knew we were going to make it. So that's the cost of manufacturing. That is the cost of making this filament, from the raw materials to the spools themselves. And speaking of the spools, we did try spoolless, and we do have a spoolless machine here, but the problem is that spoolless is kind of an overcomplicated work process. So it is way more labor than just using regular spools, and also way more unreliable, because you have to deal with all the systems and people interacting with it. And then somebody cuts a band at the other end and they ruin their spool, and it's your fault because it wasn't tied down well enough. So it just creates a lot of problems. And this is something really important to kind of like be aware of. Like when you are creating a consumer product, you are dealing with consumers. This has a customer service component to it. All of that is gone when we were making filament for ourselves. If we had a problem, well, we snip out the problem, we move on to the next spool, and we're like, oh, I'm going to give myself a bad review. That doesn't really happen. But with customers, you do have that issue. You also have the additional cost of customer support itself, where someone needs to be around to answer email. And yeah, you can automate that, and we absolutely do, but you still need to be able to chase down some stuff. Otherwise, people are just angry at you. And we live in the world of the internet, where a lot of you are watching this, and if you are all really unhappy with me, you're going to tell us down in the comments and that kind of stuff. So customer support has to remain human, just because that's how the world works. But one way of dealing with customer support is really very similar to dealing with manufacturing itself. You reduce and you simplify. So what we did with Tangled is that we said, okay, you can have any color you want, so long as it's black. Now people don't have to ask, what colors do you have? What does this color look like when I print it? Are your photos accurate? They can't ask what formats they have. They don't ask what materials we have. They don't say, does this material work with my 3D printer? We say, black PLA. Here's the settings. So it reduces customer support simply by having a smaller product line, which again saves costs so that we can reduce the cost of the filament. But now you still have marketing. And in marketing, well, we had sort of a side advantage here because we operate YouTube channels and we know how to do it. So we had a place to start where the cost of marketing was way less than somebody else. When other makers might be spending 25% of the spool cost in selling ads in order to get you to buy their spool of filament because it's PLA and one PLA is the same as another. So it's marketing that splits the difference, because it's like, oh, everybody can make shoes, but Nike has the Nike logo and brand because they spend so much on marketing, so people buy Nikes. That's what you have to do with filament when you're selling the same filament as everybody else. We were able to kind of leverage content and our existing YouTube channel to at least launch it to see if anybody cared. And then over time, the making of the filament, showing off these extrusion lines and this kind of stuff, continues to feed content so that it's reasonably low cost to market and bring this stuff up. Even this video right here is technically an ad, as I explain all the steps we went through in order to reduce the cost. So yeah, just go ahead and buy some Tangled filament. That's what we're doing here. That's my sponsored spot. So that is how we reduced the cost of manufacturing, how we reduced the cost of spooling, how we reduced the cost of customer support, and how we have reduced the cost of marketing. Also, side note, marketing can be customer support. We can make a video explaining how to print with Tangled PLA, and that both helps people and promotes the material. So these videos are just a way of helping everything, and without that, to reduce costs so that we can get it down lower. Now for the biggest monster, shipping. Filament is expensive to ship. Filament is really expensive to ship. We could handily probably drop the cost of our filament by another $10 per set if we had cheaper shipping. And this is probably one of the stupidest disadvantages that we have, in that much of Tangled is still made here in Idaho, inside of the US, but it has nothing to do with US. It has to do with the fact that we're in Idaho. And Idaho is kind of second to Alaska in being far away from places, so shipping costs are kind of high. The way to fix this is to make a whole bunch of filament, and then we move it to a distributor in the Midwest. We thought it was going to go into one of our factories in the Midwest. That factory is not available to deal with this yet, so we're still shipping from Idaho. But that is the unlock for reducing shipping. We just need to get closer to where customers are. If you ever run an e-commerce business or so, put it inside the Midwest, because 80% of the US population is east of the Mississippi. So you generally want to put yourself somewhere like Kentucky or Tennessee, so that you're right in the midst of humanity on this continent. We are not in the midst of humanity. We are in the midst of cattle ranching and farming areas that are on the wrong side of the country. So that's our problem to have to deal with, but it can be dealt with, and we're working on that. So here very soon you will see filament distribution happening in the Midwest, where we basically send a couple truckloads of filament to a place where it can be shipped from as individual parcels in order to reduce overall shipping. But the thing to remember in all of this is that Tangled is basically a side project for Slant 3D, because we actually run print farms. And this in itself is both good and bad. It's bad because Tangled filament is kind of the afterthought of all the things that we do here, even though we've been able to reduce the cost of filament from $25 down to 10. But it's good because Tangled doesn't have to make a profit the same way other filament manufacturers do. Since Tangled is part of a company that does 3D printing in general, we can basically make the benefits off of the reduced cost of filament from the scale over in the print farm and basically sell Tangled at cost rather than having to make it at a profit. We also have really reduced overhead. So like the same accountants and lawyers and even customer support people to a limited degree are able to work on Tangled and the 3D printing side for basically the same amount of effort as they were working on just the 3D printing side, or as a regular filament manufacturer would have to deal with just 3D printing, which again reduces cost, because you're basically getting a 2-for-1 deal on your accountant, because we're selling filament and selling 3D prints, but the filament isn't the main focus, so we don't have to pay off the whole accountant with just the filament itself. All right, so we talked about the cost of raw material. We talked about customer support. Just finished talking about overhead. We got a problem with shipping still. We talked about how this video itself reduces our cost of marketing. Is there anything else that we need to go over? Yeah, there is, and this one's kind of sneaky. It's also one that people don't really think about, and I did talk about a second ago. These machines. A filament extrusion line like one of these will cost somewhere between $20,000 and $80,000, depending on your size, depending where it's coming from. And yes, these machines are made in China. The reason is there is not a US manufacturer who is able to make them. But the problem even greater than this right now that we continue to deal with is, like, we would like to grow Tangled even more. But the issue is that the cost of them has increased by 50%, because if we buy one of these machines from the people who know how to make them, we have to pay a 50% import tax on them, also called a tariff. Now, there's multiple things to talk about with the tariffs. There's some good stuff, some bad stuff, or whatever else it was. A very simple solution to the whole tariff situation would be to put a tariff on finished goods and leave factory machinery alone so that factories can be brought back into the United States. That is not currently being done because the current tariffs are kind of a blunt force instrument. It is slowing us down. But the reason this matters is because the cost of our machinery increased 50%. You have to pay that machinery back. So say one of these things costs $50,000. We have to, if we are selling filament at break even, we are not paying off the machinery. That's called depreciation and amortization. If we were making $1 off of every spool of filament that we sold, then for a $50,000 machine, we would need to sell 50,000 spools of filament. 50,000 kilograms of filament is kind of a lot, and you have to make sure that there's a roadmap to doing that. This is where the tariffs can actually be useful. The tariffs have increased the cost of Chinese manufactured filament by about 50% as well. So we, as a manufacturer that makes filament at $10 per spool, are able to be even more competitive than we were before. It was at $10, we have been cheaper than Chinese filament ever since we did that, but it just makes it even more so now. But that Chinese filament now has an actual inhibition to where theoretically, maybe we can increase our scale so that a $50,000 machine can be paid off in a reasonable amount of time, because we just know we're going to sell even more than what we were when we made filament for $10 a spool anyway. But that is all politics, and you never want to build a business model around what politics is going to be. So you just look at the world as it is, and you accept it as it is, and you work within that. Also, quick aside, I forgot one thing around the shipping. The other thing we did to optimize shipping, especially now since we're coming from the middle of nowhere in Idaho, was we actually created 3 packs. We realized and did the math and found out that 3 kilograms of filament is kind of the cheapest format to ship. 1 kg, stupidly inefficient. 2 kg doesn't use the maximum weight that's in that price range. 3 kg does use that maximum weight. So that is like the optimum kind of small package that can be shipped out, which allowed us to reduce the cost. All right, one last thing, which is also kind of a subtle thing that we did that people don't really recognize, is that we did introduce a subscription. Oh, I hate subscriptions. They're all so terrible. They can't work. Everybody's always doing it. There's a subscription for everything. I get that. Please hear me out for a second. When our subscription was started out at $7 per month, at the time, the cost of shipping the filament, a 3 spool, was about averaging $8 to $10 or so. This subscription gave you access to $10 per kilogram filament, free shipping, and through a deal with another manufacturer, discounted filament from that other manufacturer. So buying the subscription was cheaper than paying for shipping on the filament, and cheaper on the material. The reason it could be cheaper on the material is because the subscription let us know what we were going to sell next month. Business is all about predictability. If you know what you're going to sell next month, then you know who you need to hire, what machinery you need to purchase, what your inventory needs to be, and how much of it you need to have. And it creates a smoother flow so that you can just be more efficient in the business itself, which can then present as cheaper cost of the filament. Now, the way we set up that subscription was kind of an issue because since it was so affordable, people would buy the subscription for 1 month and then they would cancel it the same day after they bought their filament, and it would kind of ruin the subscription. So we created kind of a bad incentive structure there that we are working on fixing right now. But ultimately, the subscription, when not abused or misused in that way, is absolutely really useful to help reduce the cost of filament overall. And this brings us to kind of like the main point of Tangled, which was to reduce the cost of 3D printer filament. The reason we did this was to prove that you could make stuff in the USA way more affordably than someone who is 5,000 miles away. But it was also to make sure that there was a supply chain in place to produce large amounts of filament really affordably. The raw materials going into filament are the same raw materials that go into injection molding. But in molding, those materials cost pennies and nickels and dimes per pound, and in 3D printing, they cost dollars per pound. There is no way that 3D printing can become a mass production technology that would take over a large part of the multi-trillion-dollar manufacturing industry if its raw materials are 10 to 20 to 50x what the raw materials of other processes are. Again, we know this because we operate one of the biggest print farms on the planet, where we constantly compete with injection molding and are constantly held up by the cost, quality, and availability of raw materials that can be printed. So Tangled is a way to accelerate this trend of the commoditization of 3D printing so that more people can get access to better cost materials, so that more stuff can be made, so that the materials can drop, so that more stuff can be made with 3D printing. So this kind of leaves the question, what's left for Tangled at this point? Well, right now, Tangled does cost $10 per kilogram. You got to get a membership, but it's over there and you can order basically as much as you want to. And you can have any color you want, so long as it's black. Also, side note, the reason we chose black is because we knew that 60% of all sales at every filament manufacturer were black PLA. So we thought you take the bulk of it first. And then all the differentiation and color variation is what wastes time and effort, which goes back to manufacturing kind of optimization and that kind of thing. But we'll discuss that more in the future at some point. That being said, we probably should introduce 1 or 2 more colors. We've done that with another filament manufacturer, but we will introduce more colors. We are held up on that by the ability to add more extruders because, like I just said, the most expensive part of making filament is changing from one color to a next, where you purge a bunch of filament out onto the ground in order to change black into blue and then blue back into black and so on and so forth. There's just all this waste of change. So you want to have one extruder basically dedicated to one material or one color and so on. Then you can be really, really efficient. Longer term, we want to start doing more advanced materials. Like, you may not realize this, but I do not know of a US-based filament manufacturer that actually makes more than one matte color. And matte colors are the easiest way to make 3D printed parts look really, really, really premium with basically no layer lines. That's about half the reason that any good 3D printer makes really good prints, is that you're just using matte filament. So that's that. Hopefully you guys have kind of learned how filament manufacturing business operates and how you can break down each one of the segments of it and just say, like, this is how it's done. Is that the correct way of doing it? Is there kind of an egregious waste in it somewhere? That's all we've been doing in Tangled. There's no real places of like egregious waste inside of filament manufacturing, but there's a bunch of little 1 to 4% weirdnesses that if you just tune them out and do good business modeling, good marketing, good product development, you can get around a bunch of them. And this is just business in general. Very rarely is there some fusion invention, some grand insight to it. It's just working on each one of the details and tweaking them until you have a really big result. We dropped the cost of filament from 25 bucks a spool down to 10 bucks a spool in a year. Not using super advanced equipment or anything else, just doing good business processes all the way through the business. Because the business is not just the product, it is everything else on top of it also. So if you can tweak all of that stuff, you can do some really cool stuff. And by the way, that applies to every type of business, not just filament manufacturing. In the context of US manufacturing, everything I just went through applies to every form of manufacturing and every product that could potentially be made over here. Have a great day, everybody.